Hey, it is Mr. Shrum, and I am back with another tutorial. And today we are going over thermal heat. No, actually, heat and thermal energy. So, see, even I messed up the naming of these, but these are two similar but different things we're talking about: thermal energy and heat. Sometimes you hear people use them interchangeably. But hopefully this lesson will help you understand how they are different. We're going to look at models that illustrate how heat flows from one object to another object at different temperatures. Here's the contents. And for a warm up, we are looking at a hot beverage cup. Waiting for the question to load. But use your experience to describe how heat flows from the drink to its surroundings. A sample answer: the hot drink heats the air in the cup that's in direct contact with the drink. The cup heats the person's hand too. Heat radiates outward from the cup. Heat moves upward when steam is produced. So that's a pretty good explanation. So this hot cup of coffee or tea is heating up the cup, and that cup can also heat up your hand if you're touching the cup directly. And then there's also steam. So heat is rising from the coffee to the air and radiating outwards. Intro video you can watch. But these three words are very closely related. And we need to know specifically what thermal energy, temperature, and heat are talking about. Atoms and molecules are these small particles that make up all matter, and they are always moving. The speed of these particles increases when a substance is heated and changes from solid to liquid to gas. And that term heated is the transfer of energy from a warmer object to a cooler object. That's how we are going to explain it for now. In liquids and gases, the particles randomly move in different directions and collide with each other. In liquids, the particles slide over each other. The image shows the motion of particles in a gas particularly. So the particles move faster and they're a lot further apart. And they fill up the entire volume of whatever container they are in. They have kinetic energy because they're moving. And the total kinetic energy of all moving particles in a substance is its thermal energy, right? So if you add up the kinetic energy of all these little particles, that's the thermal energy of that object or substance. And you can increase this energy by increasing the movement of the particles. And how we do that, we can look at this lesson activity. You'll investigate the relationship between friction and thermal energy through a simulation. In the simulation, what do you notice about the particles of the chemistry book and the physics book, what form of energy is represented by the depiction of the particles? So you're given books, slide it down so its surface touches the surface of the physics book, then slowly move the chemistry book back and forth to simulate friction. What happens to the speed of the particles of the chemistry book? So what do you notice when you do this in the simulation? What happens to the speed of the particles of the other book, the physics book? Move the chemistry book across the physics book again. Study the thermometer to determine whether there's a change in the physics book's temperature. Well, what do you find? Click the reload button. Move the chemistry book down again so its surface touches the surface of the physics book. Quickly move the chemistry book back and forth. What's different when the motion is faster? Which type of energy was transformed into thermal energy when the temperature of the two books increased? What does temperature measure based on this simulation? You've probably seen how the surface of a tire can partially melt and then leave a mark on the road when you apply the brakes super hard. Why does the surface of the tire melt? And hopefully by now you're kind of getting a feel for why and how friction leads to an increase in temperature and thermal energy. And we'll look at that in these slides. So the temperature changed when the thermal energy changed as well. So an increase in thermal energy resulted in an increase in temperature as well. The material with faster moving particles has a higher temperature. But it's important to note that temperature is not the direct measure of thermal energy, but they are related in these ways. Thermal energy is a form of energy, and it is the total kinetic energy of the particles in matter. Temperature is a measure of thermal energy, but it's the average kinetic energy of particles. So thermal energy, total kinetic energy, temperature is the average kinetic energy. So remember that distinction. There is a difference. What does an increase in the temperature of air indicate? It means that it has more thermal energy overall, and particles have sped up because more thermal energy means more kinetic energy, which means they are moving faster. The temperature depends on the thermal energy, and the thermal energy depends on the kinetic energy. Particles that move faster have more kinetic energy and thus more thermal energy overall. Yeah. And here's another word we use, heat. In physical science, it's much more specific. It's literally the transfer of energy. It's the flow itself. So heat is the flow of energy between objects at different temperature. So this red hot object over here is transferring energy to this cooler object, and we call that transfer heat. Heat and thermal energy are different. Thermal energy is the total kinetic energy of the particles. I know I keep saying that, but it's important to remember. The transfer of heat will result in an increase or decrease in thermal energy. A change in thermal energy results in a change in temperature. So as one object is transferring energy to another, there is an increase or decrease in thermal energy and a change in temperature. So we're given tiles. Just to check your understanding, average kinetic energy, temperature, the total kinetic energy of all the particles in a material is thermal energy, and the actual flow of energy between objects at different temperatures is called heat. So these are three different things that are related. The transfer of heat takes place continuously in the universe. It's difficult to study how heat behaves because it flows in all directions. But to solve this problem, physical scientists have a setup with a boundary that doesn't allow heat to leave or enter. So it's all self-contained. They put objects at different temperatures inside the boundary, and then they study what happens. So these experiments can help derive or come up with certain laws of heat transfer. And one of those laws is that heat flows from warmer to colder objects. The flow continues until the two objects reach the same temperature. And when two objects are at the same temperature, that is called thermal equilibrium. Equilibrium, think of the word equal, has the same root, but that means they are at the same temperature in contact with one another. And the amount of energy the warmer object loses equals the amount of energy the cooler object gains. Amanda places hot food on a plate. Which event will occur? Heat moves from the food to its surroundings. Because the food is hotter than the air around it, heat flows from the food to the air. The flow is from hot to cold. Hot to cold. Remember that. Select all of the correct answers. A milliliter of very hot water is added to a liter of very cold water. Which of these events will occur? So the cold water will warm to room temperature. The hot water will cool down. The cold water will warm up. So the cold water, the milliliter of hot water plus the air from around the room will warm up the cold water eventually. And the hot water cools down and the cold water warms up. So those three are correct. The hot water is losing energy and cold water is gaining energy. So heat is transferring from hot to cold. And the energy from the surrounding air also moves to the cooler water. Said that again. But this exchange of heat continues until thermal equilibrium. And another example is placing a glass of cold water and a cup of hot coffee on a table. If you check their temperatures after an hour, you'll see that the temperature of the coffee is the same as the water, even though they started out much cooler and hotter than one another. There are situations where objects do not reach thermal equilibrium. This can occur if thermal energy is added to the system of two objects. So if there is something outside of the system bringing more energy in, then that can affect how things happen. So our body temperature isn't always equal to the temperature of our surroundings. Within ourselves, we produce thermal energy from the food we eat. So we're usually warmer than our surroundings. We don't reach thermal equilibrium with our surroundings because that would not work out in our favor, actually. And I will stop there for now, and I will start another video talking about the kinds of heat transfer. And I will see you then.